I just started recording, so if you're watching the recording, sorry, you're going to have to go through the first slides by yourself and imagine me talking about them to you. But we are talking about causes of cancer here. Okay, so how do doctors determine if something is cancer or is it just a tumor? So let me ask you guys this. What would be the difference between something that is a cancerous tumor, right, which in the science world we call malignant, or a benign tumor, which means that it's not cancer, but it was a weird growing out of control thing? What's the difference between those two? Let's see. One of them can be removed and one of them can't. Good guess. The symptoms, also a good guess. Yeah, so there's many things, but malignant tumors, right? Well, first of all, technically, any tumor is technically cancer, right? Because it's an uncontrolled cell division. However, once we get into medical terminology, Marissa is 100% right. Benign means that you don't technically have what we call cancer in the medical world. Why? Because that means that tumor can't spread. It can't influence other parts of your body. Malignant tumors, as gross as it sounds, a piece of the tumor can actually break off, migrate to another part of your body, anchor itself there, influence other cells, and cause more tumors. Right? So that's what we more know as cancer, the ability to actually spread throughout the body. Benign tumor is just like a mass of cells that, you're right, you could remove it and then it's done. Right? Usually benign tumors, if they are causing any symptoms, like Michael brought up here, it's because they're, huge and maybe they're hitting something else. For example, if you have a giant tumor on your ovary, right? It might be pressing on your bladder. Maybe you're having pain from it. Once the tumor's gone, though, that will go away. Whereas a malignant tumor can actually break off, travel, and wreak havoc. So you're exactly right, Marissa. Then your entire body will become infected with it, right, if it's malignant. Now, even if a tumor is malignant, it may not have spread yet, right? And there's still opportunities to remove it. Oh yes, computer updates. I'm aware of them. I'm always like, never, never, never. Okay. So how do doctors determine though, right, if something is cancer or not? For example, you go in, you have a weird mole, right? And you're like, I don't know what's going on with my mole. Well, what would a doctor do? What do you guys think? / the words on the slide will give you a large nudging hint. Take a sample. Exactly, right? All right, let's take a little sample of your mole. And then what are they going to do with it? They're going to test it, right? And then that's the great thing about being a doctor. You say, I tested this and it says this. And they don't actually tell you about what they really did, right? Well, what they're doing is they're going to compare the rate of mitosis to an accepted value of mitosis. So what is mitosis for those of us who maybe have not gotten to the mitosis lesson yet? It's when a cell divides, exactly. Right? So cells are dividing all the time into 2 exact copies, love it, and we know that. But the question is, when is it too much? Well, so basically what has happened is doctors have composed thousands and thousands of pieces of data of what we expect, right? We expect certain cells to be dividing more than others. Where on your body do you think you have the highest mitotic index or the most mitosis happening? Lane was ready. Skin. Yeah, right? Your skin is always going through mitosis because it's always getting touched and falling off, essentially. You're leaving skin behind all over the place, even though you can't see it, right? Because it's cells. In fact, if you're allergic to dust, you're technically allergic to skin. See? Kind of sucks, right? But that's what dust is, it's skin. Pretty gross, but it is what it is. If it's in your house, it's probably your skin, so it's a little better. Hair, right? Your hair also, if it's growing quickly, your nails, right? A lot of mitosis. What about inside your body? What about your brain? Do you think there's a lot of mitosis happening in your brain? You would think so, but not really, right? Your brain doesn't really go through a lot of mitosis, which is part of the problem, right? Because some people probably need their brain to go through it a little bit more, right? But when you're growing, sure. But once you're grown, your brain doesn't do much. Stomach lining, yes, 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 right? Your stomach and your intestines, same thing, tons of mitosis. Because again, stuff is passing through them and cells are getting like sloughed off every time something goes through. So that's also another place. So again, we need to note these things. Why? Because we're not going to compare the rate of mitosis of your skin to the rate of mitosis of your liver, because they're going to be different, right? They're not going to divide at the same rate. We don't expect them to, and they don't. So doctors have this information. What is an acceptable rate? Now, the other thing is, do you think age matters? Are my cells dividing at the same rate as your cells? Yes, age matters. It does, right? If I'm older, most likely I'm not having the same level of mitosis as you guys, because you're probably still growing, right? I'm not changing size. I'm just trying to maintain, right? You're trying to grow in size potentially. So you're going to be having a higher rate of mitosis than me, right? A baby would be having a higher rate of mitosis than anyone. So age matters, right? You guys are 100% right here. Future professional doctors right here. So you are right. They take a sample. Let me close on my Zoom things. And remember this picture, right? By the way, we're going to talk about this right now because I did have a couple questions about this lab, right? So I gave you a lab with a picture of onion cells and asked you to count them, right? And figure out which phase they're in. So here's some examples of what those phases look like, but you may have experienced during the lab, if you've done it, or even just looking at this picture, how easy is it to tell which phase the cell's in? Is it like, oh, duh, that one's in metaphase? Why does that interface look so sad? It does look sad. Oh, man, you're right. That's funny. But no, what you should have been feeling during that lab is, I think this is prophase. I think this is anaphase. Yeah, it's hard, right? Because you may think this itself right here, this could still be prophase, because do the chromosomes really look lined up? I don't know, right? So sometimes it's obvious, sometimes it's not. So again, there's a percent of error in this, right? Which is why we use statistics. So this is exactly what scientists / doctors do, right? They're going to count the rate of mitotic index. How quickly are your cells going through mitosis? Is it the normal amount? Is it more? Is it less? If it's more and it's by a certain percentage, then they will say it seems like cancer, right? And then if it's not, or it's lower, they'll say, no, it's not cancer. And doctors can be wrong, right? Especially about this, because like, I think it might've been Lane who said, they take a sample, right? They don't take all the cells. They might happen to take a sample of cells that are doing what they're supposed to be doing. What happens if it's going too slow? That's a good question. I think there's like a range. I don't know. I think obviously if your cells were dividing that slowly, you wouldn't exist, right? So there is a certain level where it wouldn't happen. It wouldn't be realistic. But that could be indicative of other diseases. I don't know. All right, so how can we tell if it's statistically significant, right? So this is a little review of our statistics unit. So as a doctor, if you're going to tell someone they have cancer, you want to be 100% sure, right? You don't want to say, oh yeah, you have cancer, and then the next week, never mind, we were wrong, you don't, right? I mean, that would be nice for the person, but you also don't want it to go the other way. You don't want to say, you're fine, and then the next week, oh, just kidding, you do have cancer, right? In fact, that actually happened to one of my friends. She had a mole on her chest, and it was bothering her. It was like itching, it just felt weird, and so she kept going to her doctor, and they kept telling her that it was nothing. They kept doing tests. They said, no, it's not cancer. We don't know. Like, it seems fine, whatever. And she finally said, well, can I just get it removed? Because it's so like bothersome to me, right? Like, it was itching her like crazy. And they removed it. And then they found out it was cancer, and that she had 6 other moles on her back that were cancerous. And now she has to have chemo and do all this other stuff, right? And I mean, she's my age. She's young. This is not like someone who's like 60. And, you know, that's pretty upsetting to her, especially since she was being proactive about it, right? So doctors are not always right, unfortunately. But again, statistics helps with that, right? It's going to curb the amount. But also that's a good lesson in, if you feel like something is wrong with your body, pursue that, right? Because your intuition can be right. Yeah, your doctor said you had a 70% chance of having cancer, and then he said there was like 0. Yeah, right? So some of these things can change, and it can be frustrating. But that's why you get a second opinion. That's right. If you go to a doctor and you say, this is bothering me, and they say you're fine, then go see another doctor, right? And if you see 3 doctors and they all say you're fine, okay, right? Maybe you are fine. Wait a bit and see how you feel. But I'm telling you guys, right? If you have an intuition about something being wrong with your body, it is good to be persistent about getting it checked, right? Because it could be life or death in some situations. Okay, so back to the math part of this. Chi-squared test, right, which we used from statistics. We can compare an observed rate to an expected rate, right? Because that's what we did in chi-squared. Here's what we see. Here's what it should be. How different is it? So that's exactly what we're going to do here. Little review of chi-squared. Your neighbor has cancer and was told it was unsurgical, that it can't be removed. Yeah, and then they said it was totally, yeah, exactly, right? It is, I'm telling you guys, it's hard, right? And of course, doctors have a lot to do. I mean, they obviously can't be right about everything, but it's unfortunate when they're wrong about you or someone that you know. So remember our steps for chi-squared, right? It's this X with the little squared sign. It's pronounced chi, even though it looks like chai or chi, maybe you were thinking. Yeah, right? Doctors are humans too, exactly. But that's why you can get multiple opinions. So our equation, right, was observed minus expected squared divided by expected, and then we add all of those things up. And of course, we never had to use that equation straight up, right? We have the chart that I made to help us break it down. But basically what we're going to do is we're going to find our chi-squared value. We're going to compare it to what's expected. And if it is statistically significant, that would be a huge indicator that the person could have cancer. Degrees of freedom is the number of categories that we have minus 1. That's just going to tell us where to look on our chi-squared values. In this case, mitosis has 5 categories: interphase, prophase, metaphase, anaphase, telophase, right? PMAT, which you might have seen in the lesson, is like the major phases. Interphase is just the regular cell chilling by itself, doing what it does normally. We include that here, though, because, again, when we look at cells, we will see cells in interphase. So we need to include that. And for those of you who've done the lab, which phase should cells be in the most? Should cells be in interphase the most, prophase, metaphase, anaphase, or telophase? Interphase question mark, you're right, interphase. We should see the most cells not dividing, right? Which might seem strange because you're like, well, aren't we wanting some of them to divide? Yes. But again, they're not all dividing all at the same time, right? We should see most cells in interphase. Okay, so mitosis has 5 categories again: interphase, prophase, metaphase, anaphase, telophase. IPMAT, right? Can be a way to remember that one, like an iPhone, but with mitosis. So our degrees of freedom will be 4, which means that in our chi-squared value chart, we're going to be looking right here every single time for this, because we're always going to be talking about mitosis in this situation. Our chi-squared critical value that we're going to compare our value to is 9.488. So that's the value that we need in this particular instance. So let's do an example. You guys may remember this guy. Our chi-squared chart. I'm pasting a link in the chat. You shouldn't be able to edit it, I don't think. Let me make sure. But you can make a copy of it so that you can do your own version of this. And keep in mind, oh, this is good. Okay, good, can view. You will do, as your exit slip, you will do one of these by yourself. So it's helpful to open it and have it ready and follow along so that you can do this by yourself. So you can spend right now making a copy of it. You can call it cancer, chi-squared, you could call it biology, cancer, something, whatever. Whatever's gonna help you locate it in a bit. So here's the type of data that we would see, and we're about to fill in the chart. So I might actually have to write it on paper because, you know, 2-minute tabs. And I learned today that Lane likes tabs. I'm a fan of tabs too. You notice I have a lot open at all times. All right, so here is what we would get. Our observed rates of mitosis and our expected values. So our expected values, again, this is going to be for a specific type of cell, in this case, stomach cells, right? Because we are suspecting that this person potentially has stomach cancer. And the observed rates from the patient versus what's expected for that person, that age, right? I made like age brackets. All right, Kobe, watch the recording so you can see how to do the math if you're not sure. However, right, this is made up by me. This is not like a real chart that is actually from a doctor's office. It's made up by me based on what it should ideally be. So all we're gonna do is fill these numbers in our chi-squared chart. So let's see, we've got 60, 15, 15, 5, 60, 15, 15, 5, and then what's our telophase? 5. Okay, and again, these should add up to 100%, right? Because again, chi-squared is discrete categories. Everything has to fit in one category. So we have 100% total. Now, what was expected for this person would have been 77.5, 17, 3.52. Okay, again, should add up to 100%. And then what do we do? Well, we're gonna follow the instructions here. First step is difference squared. We're going to do observed minus expected and then square it. Can we get some volunteers to take on the phases? Lane, why don't you do interphase? Georgia, you do prophase. Who would like to do metaphase? Because you have to leave in 7 minutes, so I gotta make sure you get one in. All right, Elizabeth's gonna do metaphase, anaphase, Angela. And telophase, I'll do telophase. And if you aren't doing one, you can do telophase with me. So again, you're going to do observed minus expected, and you're going to square it. And feel free to use a calculator, right? I love calculators. All right, so again, if you're working on your math, just keep working on it and ignore me. But if you're like, what's going on? All I did was do 5 minus 2, which is 3. And then I squared that. 3 squared is 9. So I got 9 for this value. Lane got 3,066. Let's see, 60 minus 77.5 is 17.5. Yeah, are you sure? I got 306 for that one. Check your math on that one, Lane, because you should do 60 minus 77.5 squared. All right, Elizabeth, you were doing metaphase. You got 144. Okay, good. Should be 12 squared. Good. Prophase is 0.77854. 7. Okay. And then what about anaphase is 20.25. Good. All right. So that was our first step. Then our next row here, we're going to take the value we just got, right, which was our difference squared, our observed minus expected squared, and we're now going to divide it by our expected value. So for telophase, I'm going to do 9 divided by 2, and I get 4.5. So what would we get for our other ones? For interphase, we would get 306 divided by 77.5, which is 3.9. 4, 8. Thankfully, this isn't chemistry. We don't have to worry about significant figures. For prophase, we would do 0.77, 8 by 4, 7, divided by 17, which is going to be a very small number, which honestly, you want small numbers here. That's a good sign, actually. For metaphase, we're going to do 144 divided by 3. And we get 48. And thank you, Angela, jumping in with anaphase, so I don't even have to do it. 40.5, right? Because what did we do? 20.25 divided by 0.5. Okay, final step by Lane, I know you can do the rest of this by yourself, is to add all those numbers up. So let's add them up and let's see if we all get the same thing. So we're adding all the numbers in this third row here. Anyone get an answer? You think yours is wrong? Well, if you got 96.99, that's what I got, right? Whoops, I don't want it to be that ugly gray highlight, so we'll get rid of that. But all I did was add them together, right? 3.948 plus 0.0457 plus 48 plus 40.5 plus 4.5. Yeah, we get 96.9937. Yep, that's what I got too, 37. All right, so that's what we got for our chi-squared value. What were we comparing that to? It was definitely smaller than 96, right? Remember our critical value table, we are comparing to 9.488. Based on our degrees of freedom, right? This is telling us this is the number you can get Anything less than that would mean that your numbers are not that far away from what's expected. Anything greater than that means your numbers are pretty far away. Now, if it was a little bit greater, like it was like 11.4, that's one thing. Ours is 96.9937. Very different, right? Again, let's look at the data and talk about sort of why that happened in terms of math. Well, all right, come on, Google Slides. We notice, right, that our patient has a lot more of its cells in prophase, metaphase, anaphase, telophase, right? Particularly anaphase. 5% of the cells, that's a lot more than 0.5%, right? 15% in metaphase, that's a lot more than 3%. So metaphase and anaphase are the two that really impacted our numbers. So what we're doing is we're comparing our value to the critical value. Well, what did we get? We got 96.9937. Is that greater than 9.48? Yes. Right? So we would conclude from this that our person most likely has cancer. Right? And the fact that it's much greater would probably also influence, like, yeah, something's going on, right? It's not normal what's happening in those cells. Exactly. Very sad. However, helpful to know, right, that it's statistically significant. It's something that is based on statistics. It's not just the doctor thinks that, right? They would have this math and lab report to back it up. Now, does the doctor actually do this process exactly like this? No, right? But this is the concept behind what they're doing, is comparing the cells. So now, you guys are gonna do this for patient 2. Again, this is patient 2 who we're looking at now intestine cells. Their age is 75. Here are the expected values for intestine cells in a patient age 65. Again, I made these up, right? So they're not 100% true, but it's so that you can understand the concept behind this. So you're going to use that chi-squared chart, and you're going to find your critical value, and you're going to compare it to the same exact number that we compared this time, right? You're comparing to 9.88. Is your value higher than that or lower? That's going to determine if patient 2 has cancer. So once you've done your chi-squared, you're also going to answer these 2 questions, right? What does that mean? Is it statistically significant? Does the person have cancer? Yes or no? And then what is cancer in your own words, right? The scientific definition. You can also add extra stuff in there if you happen to know more about cancer, right? Or you have questions or whatever. But this PowerPoint is posted, so you can see all these numbers. You have access to the chart, right? And you now have a pretty good understanding of what cancer is, I hope. All right, so we do have a virtual session next week. It's going to be a DBA, so it's going to be short, right? I'm going to aim for about 20 to 25 minutes for next week. If you're not able to attend, you can still turn in questions for the DBA and get some credit. But again, it's going to be a short session, and then we go on the break. Your projects are due when? December 18th. That's next Tuesday, guys. That's coming up fast. Now, if you are going, uh-oh, I have not done anything for my project except maybe think about it for 3 seconds when you told us about it last time, that's fine, right? If you need to turn your project in over the break, also fine. I'm not going to take any points off. I want you to complete the project. If it takes you a month to complete it, it takes you a month. some people have already reached out to me saying, hey, I'm growing plants, or I'm doing this and I ordered this and it's going to take this much time. That's fine, right? Just be in communication with me. And remember, reach out if you're stuck, because I have ideas for you, right? And some of you have already. Hopefully that's helped you. I've sent you links. I've sent you resources, right? Literal labs that you could adapt to do your own experiment with. You can also use other people's data. So if you want to do something, but you're like, wow, this requires advanced technology that I do not have. Okay, find someone else's data and use that, right? That's totally acceptable. The purpose of this is that I want you to see how we can prove or demonstrate these processes. All right. Does anyone have any questions about the class, about this assignment, about the project that you think would benefit the overall group? Mr. Ling just came in.
Hello, students.
Well, we're just having like our final thing. All right, you're having some trouble with the website for Project 5. Good. Send me an email, Georgia. It's a complicated website. There might be better ones, but that's a one that I used to use. So send me an email. When does the break start? A great question. It starts the 20th, right? So you have school next week, Monday, Tuesday, Wednesday, and then Thursday the break starts. We don't come back until the 7th. So you've got a lot of time off, or a lot of time to get your work done if you have not been. So I will check my email during the break, probably not every day, right? But I will check it. So if you get stuck, even during the break, you can email me, right? And I'll reply pretty quickly. Yeah, if you're having trouble with 5, send me an email. Georgia, tell me, maybe exactly what you're trying to do so I can see how to troubleshoot it. So next Wednesday is the last day before break. Yep. And a lot of people might not have virtual sessions next week, right? So be listening and looking for emails from your teachers, but we are having one for this class. So I will see you guys next Tuesday for our DBA. It's going to be short. We'll talk more about project stuff, especially since I know a lot of you will start your project this week and you'll probably have questions. But send me emails if you're stuck, and otherwise I will see you guys next week. Okay, Michael. Yeah, a lot of people are. That's fine. Thank you for letting me know.